Today we are going to discuss about object-oriented modeling. An object-oriented model is an object-based model for modeling system requirement. It disseminates a complex software requirements into simple, well-defined pieces called objects. Object-oriented model brings reusability, maintainability, and productivity in system design. In the object-oriented modeling, the object is an entity which is used for representing or modeling a particular piece of the system. Each object is characterized by a set of unique behavior and state. So, in an object-oriented modeling, the main component is object, and each object has a set of unique behavior and a state. Then another one is class. A class is an abstract description of a set of objects, and can be considered as a blueprint of an object. A class represents the state of an object through member variables and object behavior through member function. So a class is known as the blueprint of an object. So it has a class has a state and its behavior. So state is represented through member variables and object behavior through member function. The member variables and member functions of a class can be private, public, and or protected. What is meant by a private member variable? Private member variable and functions are accessible only within the class, whereas a public variables and functions are accessible within the class as well as outside the class. The protected variables and functions are protected from external access. However, these classes derived from a parent class can also access the protected member function and variable. So there are three types of access specifier in an object, that is private, public, and protected. Private member variables and functions accessible only within that class. Protected variable can be accessible from the parent. The classes derived from the parent also access the protected member functions and variables. So the concept of an object and class brings abstraction, hiding, and protection. So the representation of an object and a class. An object diagram is similar to a class diagram, except it shows the instance of the classes in the system. Here, actual classifiers and the relationship making the use of class diagram. The object diagram represents specific instance of the classes and relationship between them at a point of time. Object diagram use real-world example to depict the nature and structure of the system at a particular point in time. Object diagram provide a clearer view of the relationship that exists between objects. So നമുക്ക് two types ആണ് ഒബ്ജക്റ്റിനെയും ക്ലാസ്സിനെയും റെപ്രസെന്റ് ചെയ്യാം. ഒബ്ജക്റ്റ് റെപ്രസെന്റ് ചെയ്യുന്നത് നമ്മുടെ ഒബ്ജക്റ്റ് ഡയഗ്രം റെപ്രസെന്റ് ചെയ്യുന്നത് നമ്മുടെ ഒബ്ജക്റ്റ് തമ്മിലുള്ള റിലേഷൻഷിപ്പും അതുപോലെ ഒബ്ജക്റ്റിന്റെ സ്ട്രക്ചർ എല്ലാമാണ്. This is the representation of a class in a UML model. The class is represented within a rectangle and it has three sections. First, it indicates the class name, then attributes, then functions, member functions. So here bank account is the class name and balance is the attributes, which is long int, and account valid till is another attributes, as its value is date. Type is date, and it has two function, one is withdraw and show balance of, and it returns function boolean. Withdraw returns a function boolean, and show balance is another member function which returns long int. And here it is plus indicate it is a public variable. And object, here object name is account1. Here account1 colon bank account indicate that this is the object of a class bank account, and its object name is account1, and its value, here variables balance and account valid till, and its value balance is the value is assigned here. That is object എന്ന് പറയുമ്പോൾ എന്താണ്, ഒരു ഇൻസ്റ്റൻസ് ഓഫ് ടൈമിലുള്ള ആക്ച്വൽ വാല്യൂസ് ആണ് ഇവിടെ റെപ്രസെന്റ് ചെയ്യുന്നത്. Then account valid till, corresponding value will be, date will be given here. And this is an example of a class and object representation. We can also specify the functions here. The next one is UML. UML is a unified modeling language, which is a visual modeling language for object-oriented design. UML helps in all phases of system design through a set of unique diagrams for requirements capturing, designing, and deployment. So, the building blocks of UML. There are mainly 3 building blocks are present in a UML diagram. First one is things, second one is relationship, and third one is diagram. What is a thing? Thing is an abstraction of the UML model, and relationship is the entity which expresses the type of relationship between the UML element. The UML elements are object and class, etc. So the relationship between this object and class are represented by this relationship. And third point is diagram. UML diagram give the pictorial representation of static aspects, behavioral aspects, and organization and management of different modules of the system. So these are the 3 main building block of UML diagram. First one is things. Things are again classified in different groups. First one is structural things. In structural things represents mostly the static part of the UML model. So UML model static part will be represented by the structural things. It is also known as classifiers. So here the structural things in UML are represented by class, interface, use case realization or collaboration, active class, components, and node. This is the structural. So structural is class. Class is represented here. Here the first is identifier, then variables, then methods are represented. So here class is a template describing a set of objects which share the same attributes, relationship, operation, and semantics. It is considered as a blueprint of the object. The next one is active class. Active class which is similar represented in the similar way as that of class, but here it is a thicker border. That is an important one. Here it is a thicker border than the actual class. So first identifier, variables, and methods. There are 3 sections are there. So this class represents a thread of control in the system. So it can initiate control activities. So mainly active classes are used to initiate control activities. The next one is interface. Interface is a collection of externally visible operation which specifies a service of a class. So it specifies the service of the class, and it is represented as a circle attached to the class. So a class is attached with a circle, then it represents the interface. The next one is use case. It defines a set of sequence of actions. So it is normally represented within a ellipse indicating the name. It indicates the name. So it specifies the sequence of actions. Then next one is use case, realization or collaboration. Here the diagram specify the collaboration of different use cases. So it normally represented dotted ellipse indicating the name. Dotted ellipse. Then next one is component. It is physical packaging of classes and interfaces. So the collection of classes and interfaces are known as component, and it is represented like this. And node. Node is a computational resource existing at a runtime, and it is represented by a cube with a name. So node is represented as cube with name, and it is a computational resource existing at a runtime. Then second one is behavioral things. It represents the dynamic part of the UML model. In a structural things, it represents the static part. In a behavioral things, it represents the dynamic part. It containing interaction, state machine, and activities. So interaction means behavior comprising a set of objects exchanging messages to accomplish a specific purpose, and it indicates the represented by an arrow with the name of the operation. So നമുക്ക് ഡൈനാമിക് പാർട്സ് റെപ്രസെൻറ്റ് ചെയ്യാനാണ് ബിഹേവിയറൽ കോമ്പണൻസ് യൂസ് ചെയ്യുന്നത്. അപ്പം ഇൻട്രാക്ഷൻ എന്ന് പറഞ്ഞാൽ രണ്ട് ഒബ്ജക്റ്റ് തമ്മിൽ മെസ്സേജ് എന്തെങ്കിലും ഒരു സ്പെഷ്യൽ പർപ്പസിന് വേണ്ടിയിട്ട് മെസ്സേജ് എക്സ്ചേഞ്ച് ചെയ്യുമ്പം ആ മെസ്സേജ് റെപ്രസെൻറ്റ് ചെയ്യുന്ന ഒരു ആരോ യൂസ് ചെയ്തിട്ടാണ്. ഒരു ഒബ്ജക്റ്റിൽ നിന്ന് അനദർ ഒബ്ജക്റ്റിലേക്ക് എന്തെങ്കിലും മെസ്സേജസ് ചെയ്യുന്നതിനെയാണ് ഇൻട്രാക്ഷൻ എന്ന് പറയുന്നത്. അപ്പോൾ ആരോ യൂസ് ചെയ്യും. അതുപോലെ തന്നെ ആ ഓപ്പറേഷൻ്റെ ഇപ്പോൾ എന്ത് മെസ്സേജാണ് ട്രാൻസ്ഫർ ചെയ്ത് ആ കറസ്പോണ്ടിങ് ഓപ്പറേഷൻ്റെ നെയിമും സ്പെസിഫൈ ചെയ്യും. ദെൻ സെക്കൻഡ് വൺ ഈസ്
next behavioral things is state machine. We know that state machine containing states and events. Here in this behavior specifying the sequence of states in response to events through which an object traverses during its lifetime. So state is represented using a rectangle and it containing the name of that state, and there is a transition from one state to another is occurs when an event is occurs. The next thing is grouping things. These are the organizational part of the UML model. Package and subsystems are the grouping things in UML. So package is the something of the grouping. Here package is represented like this symbol, and organize elements into packages. It is only a conceptual things represented as tabbed folder with name. And next one is annotational things. If we want to give an explanatory parts or an explanatory notes, then we use annotation, and one of the component of annotational thing is note. Here explanatory element in the UML model, and it contains formal or informal explanatory text. It may also contain embedded images. The next one is relationship in UML. There are different types of relationship between UML object, class, etc. Here association, aggregation, composition, generalization are the example of relationship. Association, it is a a structure relationship. It is a structural relationship that describing the link between objects. So association can be one to one or one to many. Aggregation and composition are two variants of association. So association indicate the link between two objects. So here the it may be one to one or one to many, and the relationship is represented in above the arrow. There are two types of associations are aggregation and composition. Here aggregation represents the part of relationship represented by a line with hollow diamond at the end. That is a part of, that is engine is a part of vehicle or car. അങ്ങനെ സ്പെസിഫൈ ചെയ്യാൻ വേണ്ടിയിട്ടാണ് അഗ്രിഗേഷൻ യൂസ് ചെയ്യുന്നത്. കോമ്പോസിഷൻ, aggregation with strong ownership relationship to represent the complex component of the complex object. It is represented by line with solid diamond at the end. And generalization means it is a represents a parent child relationship. Mainly inheritance are represented using generalization. The parent may be more generalized and child being specialized version of parent type. So here it is represent child and with a arrow like this. This is the inheritance parent. This is generalization. Next one is relationship is dependency. Represents a relationship in which one element uses or depends on another. So dependency represented here by a dotted arrow with head pointing to dependent element. So if here it is represent the dependent element. Next one is realization. The relationship between two elements in which one element realizes the behavior specified by the other. So element 1 and element 2 is represented here. It is also represented with a dotted arrow, one end containing the hollow triangle. Then this is the state diagram, and here alarm a special type of audio visual indication, that is generalization is represented here. And this is the first one is generalization, that is alarm is a class and is this is a child class. Alarm is a child class that containing two members, start and stop. Then audio visualizer visual indicators is the parent class, and it containing start, stop and set type. So it inherits the features of start and stop from the audio visual indicator. Then another one is a alarm. Alarm as a, we can represent it as it's a part of warning system. So it indicates the part of warning system. So alarm containing the function start and stop, and warning system containing alarm, function and display. So it indicates the aggregation, that is a part of warning system. Then next one is seatbelt warning system UML model. Here it represents the alarm class. Alarm class how to represent? First it indicate the name of the class, then its attributes or variables, then next its function. It containing start the alarm and stop the alarm, two function. Then state representation. State representation of a alarm on state. So it is within this
rectangle we are represents that alarm on. This is the state representation of the alarm. Then here we represents alarm timer class interaction for the seat belting warning system. So how to interact? It represents a link between the one class to another class. So timer class containing attributes period, then set to time, it for setting the time for timer, and there is a start function to start the timer, and stop function is to stop the timer. So there is a relationship between alarm and timer, it indicated by an arrow. Then last one is UML diagram. It gives the pictorial representation of static aspects, behavioral aspects, and organization and management of different models. Modules means is into classes and packages of the system. Then static diagram represents the static or structural aspect of the system. Example of static diagrams are class diagram, object diagram, component diagram, package diagram, composite structure diagram, deployment diagram are. These are the static diagram. So object diagram gives the pictorial representation of a set of objects and their relationship, and it represents the structural organization between the objects. The next one is class diagram. It gives the pictorial representation of different classes in UML model and their interfaces, their collaborations, interaction, and relationship between the classes. It captures the static design of the system. Then component diagram, which is the pictorial representation of the implementation view of the system. It comprises of components, that is physical packaging of classes and interfaces, relationship and association among the components. Then next one is package diagram. It represents the organization of packages and their elements. Package diagrams are mostly used for organizing use case diagram and class diagram. Deployment diagram, it is a pictorial representation of the configuration of runtime processing nodes and components associated with them. അപ്പം നമുക്ക് ഡയഗ്രംസ് ഡയഗ്രംസ് ആണ് പറയുന്നത്. ഫസ്റ്റ് സ്ട്രക്ചറൽ ഡയഗ്രംസ് ആണ്. അപ്പോൾ സ്ട്രക്ചറൽ ഡയഗ്രത്തിൽ നമ്മൾ ഒബ്ജക്റ്റ് ഡയഗ്രാം, ക്ലാസ് ഡയഗ്രാം, കോമ്പണൻറ്റ് ഡയഗ്രാം, പാക്കേജ് ഡയഗ്രാം, ഡിപ്ലോയ്മെൻറ്റ് ഡയഗ്രാംസ് ആണുള്ളത്. അപ്പോൾ ഒബ്ജക്റ്റ് ഡയഗ്രം എന്ന് പറയുമ്പോൾ ഒബ്ജക്റ്റുകളെ, കുറേ ഒബ്ജക്റ്റിനെ അതിൻ്റെ റിലേഷൻഷിപ്പിനെ റെപ്രസെൻറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് പിക്ചോറലായിട്ട് റെപ്രസെൻറ്റ് ചെയ്യുന്നു. ക്ലാസ് ഡയഗ്രാം എന്ന് പറഞ്ഞാൽ ക്ലാസ്സസ് തമ്മിലും അതുപോലെ തന്നെ ഇൻ്റർഫേസ് തമ്മിലും, ക്ലാസ് ഇൻ്റർഫേസ് എല്ലാം റിലേഷൻഷിപ്പിനെ എല്ലാം റെപ്രസെൻറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് നമ്മൾ ക്ലാസ് ഡയഗ്രാം യൂസ് ചെയ്യുന്നത്. കോമ്പണൻറ്റ് ഡയഗ്രാം എന്ന് പറഞ്ഞാൽ ഒരു സിസ്റ്റത്തിൻ്റെ ഇംപ്ലിമെൻറ്റേഷൻ എങ്ങനെയാണ് അതിനെ പിക്ചോറലായിട്ട് റെപ്രസെൻറ്റ് ചെയ്യാനാണ് കോമ്പണൻറ്റ് ഡയഗ്രാം യൂസ് ചെയ്യുന്നത്. അതിൽ യൂസ് ചെയ്യുന്ന പാക്കേജസും ക്ലാസ്സസും അതിൻ്റെ എലമെൻറ്റ്സ്, ഓരോ പാക്കേജിലെ എലമെൻറ്റ്സിനെല്ലാം റെപ്രസെൻറ്റ് ചെയ്യാനാണ് പാക്കേജ് ഡയഗ്രാം യൂസ് ചെയ്യുന്നത്. നമുക്ക് ഡിപ്ലോയ്മെൻ്റ് എന്ന് പറയുമ്പോൾ നമ്മൾ റൺ ടൈമിൽ എങ്ങനെയാണ് അത് റെപ്രസെൻറ്റ് ചെയ്യുന്നത്, ഓരോ നോഡിനെ എങ്ങനെയാണ് പ്രോസസ്സ് ചെയ്യുന്നത്, അതിൻ്റെ കോമ്പണൻസ് എല്ലാം എങ്ങനെയാണ് റൺ ടൈമിൽ അസോസിയേറ്റ് ചെയ്യുന്നത്, അതിനെ റെപ്രസെൻറ്റ് ചെയ്യാനാണ് പിക്ചോറിയൽ റെപ്രസെൻറ്റേഷനാണ് തന്നെയാണ് ഡിപ്ലോയ്മെൻറ്റ് ഡയഗ്രാം എന്ന് പറയുന്നത്. The next one is behavioral diagram. Behavioral or dynamic aspects of the system is represented using behavioral diagram. Example is use case diagram, sequence diagram, state diagram, communicate diagram, activity diagram, timing diagram, and interaction diagram. Here it represents the use case diagram of for a seatbelt warning system. In this case, use case is represents enable or disable the alarm. This alarm is used by the actors like alarm, ignition key, and seat belt key. These are interacted with this alarm. So there is a seat belt warning system. So if ignition key is on, then we need to check if a seat belt is on or off. Based on that, alarm is enabled or disabled. Then another sequence diagram for seatbelt warning system. Sequence diagram for seatbelt warning system. Here objects are represented at the top. There is ignition keys there, then there is a timer, then seat belt, then alarm, then alarm timer. So ignition key, first ignition key is triggered on, then timer is wait for 10 seconds, then this ignition key is on for this much time. So alarm on ആവുന്നവരെ എന്തായിരിക്കും, ignition key is on, then here it is wait for 10 seconds, and after that we are checking that if seat belt is off. If seat belt is off, then it time out. Otherwise, if seat belt is on, if it is off, then alarm is turn off. If seat belt is ignition key is on and seat belt is off, then alarm is triggered. Then after alarm the timer. After timeout of the timer, if the alarm timer is expires, then alarm is turned off. This is the cases. This is represented by the sequence diagram. Here vertical line represents the life of this each object. That's all about UML diagram.